Today we will discuss the remaining questions in the electrostatics chapter. In last class we have discussed the questions up to question number 5. Now the question number 6. So in the question number 6, what is given? 4 point charges plus Q, minus Q are placed respectively at the corners A, B, C, D of square of side A. The electric field at the center of the square is, options are given. So in these options, the option C, 1 upon 4 pi epsilon naught, 4 root Q. In option C, root 2 is missing. Now let us solve the questions. Here it is a square of side A. The charges are placed at the 4 corners A, B, C, D. At A, plus Q charge. At B, plus Q charge. At C, minus Q charge. At D, once again minus Q charge. Now here we need to calculate the total electric field at the center of the square. So we know the formula for the length of the diagonal AC is equal to BD is equal to root 2 into side. So to calculate electric field at the center, we need a distance AO is equal to BO is equal to CO is equal to DO, that I represent those by notation R is equal to half the length of the diagonals root 2 into side divided by 2. Root 2 as it is, what is the side of the square? A divided by 2, which we can write root 2 into A. Here this 2 can be written as root 2 into root 2. 1 root 2 cancel. Then the distance is A divided by root 2. Now let us calculate the electric field at the center of the square. What is the formula of electric field at the center of the square? Electric field at the center of the square is given by 1 upon 4 pi epsilon naught charge divided by distance square. Here this is the formula of electric field. Electric field is a vector quantity, so it has a direction. The direction of electric field is radially outward for a positive charge and radially inward for negative charge. Now see the formula. Electric field depend on two factors, charge and distance. Magnitude of electric field depend on charge and distance. Here in this case, AO is equal to BO is equal to CO is equal to DO. The distances are same. The magnitude of charges are also same. So the total electric field at the center, electric field due to a charge at A is E1 equal to electric field at O due to charge at B is E2. Electric field at O due to charge at C is E3. Electric field at O due to charge at D is E4. All are equal and those are given by the formula 1 upon 4 pi epsilon naught charge will be Q as it is. What is the distance of AO, BO, CO, DO? The distance is A divided by root 2. The whole square. On further simplification, we get charge Q divided by A square divided by 2. This 2 goes to numerator On further simplification, what do you get? 1 upon 4 pi epsilon naught charge q divided by a square root cancel divided by 2, which is 1 upon 4 pi epsilon naught. This 2 goes to numerator, 2q divided by a square. Now let us see the directions of E1 and E2, E3 and E4. E1 is because of what? Positive charge, so which is directed radially outward. So here this is E1. E2 is also because of positive charge, directed outward. And E3 is because of negative charge, radially inward. Because negative charge, electric field due to negative charge, radially inward. And E4 is also because of negative charge. Okay, so now let us see what is the angle between E1 and E3. Theta between E1 and E3 is 0. Both are along OC. So therefore the resultant of E1 and E3, I will write it as E5 is equal to E1 plus E3. So here E1 is equal to E2 is equal to E3 is equal to E4, so that I can write E1 plus E1 is equal to 2 times E1, 2 times E1 equal to E2 equal to E3 equal to E4. So E1 is equal to what? 1 upon 4 pi epsilon naught 2q divided by distance a square. If we simplify this further, we get E5 is equal to 2 into 2 4 into 1 upon 4 pi epsilon naught q divided by a square we get. Similarly, the angle between E2 and E4 also 0. Angle between E2 and E4 both are acting along OD, so angle between E2 and E4 is also 0. That we write theta is equal to 0 between those two. So therefore the resultant of E2 and E4 will be E6. Just we are giving notation as a E6. Then it will be E2 plus E4. Now see, according to this, E1 equal to E2 equal to E3 equal to E4. So E2 is equal to E4. Then I can write it as 2 times E2. 2 times, what is the value of E2? 1 upon 4 pi epsilon naught 2q divided by a square. E6 is equal to 2 into 2 4, 2 into 2 4, 1 upon 4 pi epsilon naught q divided by a square we have. So this is E6. Now what is the direction of E5? The direction of E5 is same as the direction of E1 or E3. This is the direction of E5. Now what is the direction of E6? The direction of E6 is same as the direction of E2 or E4, which is E6. Now see, what is the angle between E5 and E6? It is 90 degree. So as the angle between E5 and E6 is 90 degree, net electric field can be calculated using a formula E5 square plus E6 square plus 2 times E5 into E6 into cos, what is the value of theta? 90 degree. So I am substituting theta is equal to 90 degree. So then E net, what is the net electric field? Cos 90 is equal to 0. Before that, here I will write it as E phi square plus, see, what is E phi? 4 times 1 upon 4 pi epsilon naught q divided by a square. What is E6? 4 times 1 upon 4 pi epsilon naught q divided by a square. It means E phi is equal to E6, which I can write it as E6 equal to E phi square. Now here cos 90 is equal to 0. 0 into anything is equal to 0. So once again here we have E phi square plus E phi square is equal to 2 times E phi square. So then I can write it as under root E square root cancel 2 root E phi. Then what is E phi? E phi is equal to root 2 into 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught 4 into q is equal to 4q divided by a square. So which I write that net electric field as 1 upon 4 pi epsilon naught root 2 into 4q divided by a square. Now see which option is correct. Option C is the correct answer. Now let us solve the next question, which is question number 7. Question number 7. In question number 7, a cube of side B has charge q at each of its vertices. What is the electric field at the center of the cube? So we have a cube of side B, a charge q at each of its vertices. At each vertices we are placing equal and identical charges. Then what will be the electric field at the center of the cube? What is the electric field at the center of the cube? Now we have to calculate electric field. Now see, here there is a symmetry. Here in this question we have symmetry. So the net electric field at the center of the square becomes 0 because there is a symmetry. What do you mean by symmetry? So at this point, electric field because of this charge is cancelled by this charge. Electric field at this point because of this charge is cancelled by this one. Electric field here because of this charge is cancelled by this. Electric field here because of this charge is cancelled by this. So net electric field at the center of the square cube becomes 0. Similarly, if I consider a square and charge q is placed at the 4 corners of the square, then what will be the electric field at the center? 0, because here also we have symmetry. Okay, so which option correct in this equation? Option D is the correct answer. Now let us solve the next question. Question number 8. Electric field due to extremely short dipole at a distance r from it is proportional to electric field due to an extremely short dipole. Electric dipole is equal and opposite charges separated by short distance, which the distance of separation is represented by notation 2a. Now we are calculating electric field at a point on an axial line. We call this point as axial line. electric field at a point on an axial line is given by the formula. Calculated formula is E is equal to 1 upon 4 pi epsilon naught 2pr divided by r square minus a square to the power 2. If value of r is too large compared to a, then a square in a denominator can be neglected. So when we neglect a square in denominator, we have 1 upon 4 pi epsilon naught 2p r divided by, we are neglected this a square, r square to the power 2 is equal to r to the power 4. On simplifying this, we get the result 1 upon 4 pi epsilon naught 2p divided by r cube. Electric field at a point electric field at a point on axial line is inversely proportional to r cube. Now what about electric field at a point on equatorial line? So electric field at a point on equatorial line is given by E is equal to 1 upon 4 pi epsilon naught p divided by p is a electric dipole moment divided by r square plus a square to the power 3 by 2. For short dipole, the value of r is too large compared to a, so we are neglecting a square. Then E is equal to 1 upon 4 pi epsilon naught p divided by, we are neglected r square, so r square to the power 3 by 2, 2 to get cancelled. Once again we have r cube. Here also that electric field is inversely proportional to r cube. So in both case, electric field at a point due to an electric dipole is inversely proportional to r cube. So which option correct? Option C will be a correct answer. Next, question number 9 we will solve. Number of electrons in a 1 coulomb charge. How many electrons make 1 coulomb charge? According to quantization rule, Q is equal to N into E. N represents number of electrons. What we have to calculate? How many electrons are there in a 1 coulomb charge? So on simplifying this, what we can write? N is equal to Q divided by E. So value of N, what is the value of Q? 1 coulomb divided by charge on electron 1.6 into 10 raised to minus 19 coulomb. So we get 1 upon 1.6 into 10 raised to minus 19 is equal to 6.25 into 10 raised to 18 electrons make 1 coulomb charge. How many electrons? 6.25 into 10 to the power 18 electrons make 1 coulomb charge. So option A is 5.46 into 10 to the power 29, the correct answer. Option B 6.25 into 10 to the power 18. So this will be a right answer. Now let us solve the question number 10. Two like charges of magnitude Q1 is equal to 1 into 10 raised to minus 9 coulomb. Q2 is equal to 9 into 10 to the power minus 9 coulomb are separated by distance 1 meter. Then the point on the line joining the charges where the force experienced by charge placed at that point is 0. What do you mean by this question? In this question, what they are asking? We have charge Q1 and we have another charge Q2. The distance between Q1 and Q2 is 1 meter. We have some point, let us say P. If I place any charge at this point, will not experience any force. What should be the distance of that point from any one charge? Now let us consider the distance of point P from Q1 is equal to x. If this point P is x from Q1, then the same point will be at a distance 1 minus x meter from Q2. So net force acting at a point P is equal to 0. We call this point as the null point. We can solve this question in detail also, and also using a shortcut formula. X is equal to d divided by under root Q2 divided by Q1. If two charges are like charges, here they are given two charges like charges, it is plus. If the charges are unlike charges, this will be minus. Plus 1 I will write here. Then I am substituting value x. What is the value of d? D is equal to 1 meter divided by under root Q2. What is the value of Q2? 9 into 10 raised to minus 9 divided by, what is the value of Q1? 1 into 10 raised to minus 9 plus 1. Minus 9 cancel. Then x is equal to 1 divided by square root of 9 is 3 plus 1, which can again be written as x is equal to 1 divided by 4. So the value of x equal to 0.25 meter. From which charge? It is 0.25 meter from 1 into 10 raised to minus 9 coulomb charge. Now let's check the options. Option A, 0.25 meter from 0.25 meter from a charge 1 into 10 raised to minus 9, which we got a result. Next see the option B, 0.75 meter from 9 into 10 to the power minus 9. See here, if point P is at a distance 0.25 meter from Q1, then the point P is 1 minus 0.25 is equal to 0.75 meter from Q2, which is also correct. 0.75 meter from charge 9 into 10 to the power minus 9. So what we have, which option is correct? Both 1 and 2 are correct answers. Now the question number 11. When the distance between two charged particles is halved, the coulomb force between them becomes. What happens if we reduce the distance between two charges to half the initial value? Now here we have charge Q1, charge Q2 separated by distance r. Then the force between these two forces is F1 is equal to 1 upon 4 pi epsilon naught Q1 into Q2 divided by r square, which I will write it as equation number 1. In next case, the coulomb force between them becomes when the distance between the charged particles is halved. When the distance is halved. Now here this is a charge Q1, charge Q2. The new distance will be half the initial value. Now the new force is F2 is equal to 1 upon 4 pi epsilon naught product of charges Q1 into Q2 divided by distance r dash square. Once again we can write it as 1 upon 4 pi epsilon naught Q1 into Q2 divided by, what is r dash? R dash is r divided by 2 the whole square. So F2 is equal to 1 upon 4 pi epsilon naught Q1 into Q2 divided by r square divided by 4. F2 is equal to 1 upon 4 pi epsilon naught as it is Q1 into Q2 divided by distance r square. This 4 will goes to numerator, that I write into 4. From equation 1 upon 4 pi epsilon naught q1 into q2 divided by r square is equal to what? f1. So finally our answer is f2 is equal to 4 times the initial force f1. Now see the option. Option A becomes 1/2, no. Becomes 1/4, no. Doubled, no. Becomes 4 times. Here new force becomes 4 times the initial value. So option D is a correct answer. Now let's solve the next question, 12. This is a basic question. The minimum value of charge on any charged body. The minimum value of charge on any charged body is equal to 1.6 into 10 raised to minus 19. So the option A is the correct answer. Now the question number 13. Charge Q is placed at the center of cube of side A. The electric flux through any one face of the cube. So here we are considering a cube. This is a cube. Charge Q is placed at the center of the cube. Charge Q is placed at the center of cube of side A. The electric flux through any one face is that we have to calculate. For that, what we do, we are applying Gauss Law. Gauss Law, what it states, the total electric flux through any closed surface is equal to 1 upon epsilon naught times the total charge. So in this case, the total flux through cube is 1 upon epsilon naught. What is the value of charge? Q. This is flux through a cube. As the cube contains 6 faces, 1, 2, backside 3, 4, 5, 6, then that flux has been divided into 6 equal parts. Then flux through any one face will be 1 divided by 6 into Q by epsilon naught. Now see which option correct? Q by epsilon naught? No. Q by 3 epsilon naught. Option C, Q divided by 6 epsilon naught is the correct answer. Now go to the question number 14. What is the question? Total charge Q, capital Q, total charge capital Q is broken into 2 parts, Q1 and Q2. It means Q is broken into Q1 plus 2 parts, that is Q is equal to Q1 plus Q2, placed at a distance R. At one point we are placing charge Q1, at another point we are placing charge Q2, separated by distance R. The maximum force of repulsion between them will occur when anta question. Then here the options are given. We have to calculate the maximum force when we divide that charge into the following parts. So here I will write Q1 is equal to Q minus Q2. Now let's write the force between these two charges. What is Coulomb's law? 1 upon 4 pi epsilon naught, product of magnitude of charge. One is Q1, another is Q2, and the distance between them is R square. For maximum force, okay, further we need to substitute the value 1 upon 4 pi epsilon naught. I am substituting value of Q1 here. Q1 is equal to Q minus Q2 into Q2 divided by r square. So once again force F is equal to 1 upon 4 pi epsilon naught Q into Q2 minus Q2 into Q2 square divided by r square is the equation we got. For maximum force, dF divided by dQ2 must be is equal to 0. This is the condition for a maximum force. Now we are differentiating this force with respect to a charge Q2. Now D divided by dQ2. Here this is constant, so which I take outside. I am not differentiating this 1 upon 4 pi epsilon naught. Then r square is also constant, which also I am not differentiating. Then what are the variables? Q into Q2 square, Q into Q2 minus Q2 square is equal to 0. Now see, 4 pi epsilon naught r square into 0 is equal to 0. Then here capital Q is constant. Differentiation of Q2 with respect to Q2 is 1 minus differentiation of Q2 will be 2 times Q2 is equal to 0. Here I will consider this as equation number 1. Then now 2Q2 is equal to Q, then Q2 is equal to Q by 2. We got the value of Q2. Now substitute value of Q2 in equation number 1. What we get? Q1 is equal to capital Q minus, what is Q2? Q by 2. Then Q1 is equal to, on taking LCM, it will be 2. This is Q2. So 2Q minus, we are calculating it 1 minute, we'll do once again. Here we are substituting the value of Q2 in equation number 1. In equation 1, Q1 is equal to capital Q as it is minus, what is value of Q2? Q2 is equal to Q by 2. Then Q1 is equal to, take LCM, which is 2. 2 into Q is equal to 2Q minus Q. 2Q minus Q is equal to Q by 2. So we got Q2 is equal to Q by 2 and Q1 also equal to Q by 2. So then which option is correct? Option A, Q2 is equal to Q by 2, Q1 is equal to Q minus capital Q divided by 2. Capital Q divided by 2. Now see the option B, Q2 is equal to Q by 4, Q1 is equal to Q minus 2Q by 3. Option C, Q2 is equal to Q by 4, Q1 equal to 3Q by 4. Option D, Q1 equal to Q by 2, Q2 is equal to Q by 2. Now here we have two options which are correct. Option A is also correct, option B also correct, because we got Q2, see Q2 is equal to Q by 2, and we got Q1 is equal to Q minus Q by 2, Q minus Q by 2, and also we got Q2 is equal to Q by 2 and Q1 is equal to Q by 2. So option D as well as option A's are having correct answers. Okay, thank you. Today we solved up to a question number 15. In the next class we will solve the remaining questions.